All right, so this lesson is over congruent polygons. A lot of what we will learn is how to use congruent statements to mark congruent parts of figures. The congruent statement is really all we need sometimes, and you'll see that it's pretty handy. So the learning goal says students will be able to identify and use corresponding parts, and then we will learn and use third angles theorem. And again, third angles theorem is something that we've probably used. We just didn't know it was a thing, so it shouldn't be too complicated. Again, in your own notes, you can summarize what you feel is useful for this. It just, again, is talking about identifying and using corresponding parts. So it says, recall that two geometric figures are congruent if and only if a rigid motion or a composition of rigid motions maps one of the figures onto another. We talked about that last chapter with transformations. It says a rigid motion maps each part of the figure to a corresponding part of its image. Again, corresponding parts are the ones that kind of match up. Because rigid motions preserve length and angle measure, corresponding parts of congruent figures are congruent. In congruent polygons, this means corresponding sides and corresponding angles are all congruent. So it says when triangle DEF is the image of triangle ABC after a rigid motion or a composition of rigid motions, you can write the congruent statements for the following angles. So we can see down here. Before I slide down, I want to draw your attention to that corresponding parts of congruent figures are congruent. When we do proofs this chapter, again, remember that was the CPCTC. So again, that was this right here that we talked about in a previous chapter. We'll use it quite a bit this chapter. So here are our congruence relationships. You can see the angle congruence relationships on the left, the side congruence relationships on the right. Up above, that's your congruence statement. So some of your problems in your homework will ask you to write another congruence statement. Again, simply just change the order. So another one would be something like triangle CAB is congruent to triangle FDE. So those two congruent statements are saying the same thing. They mean the same thing. The parts match up how they're supposed to. But in your homework, when it asks you to list the corresponding parts, if it's a triangle, you should have 3 sides and 3 angles. If it's a 5-sided shape, a pentagon of any kind, you should have 5 angles and 5 sides. You should have all the parts that you need. So keep that in mind. Don't just list out 1 or 2. Identifying the corresponding parts. So again, it says write a congruent statement for the triangles and identify all pairs of corresponding parts. So I like to start with the angles. So we'll go angle L should be congruent to angle R. The next one that has 2 arcs is angle J is congruent to angle T. And then the one that has 3 arcs, angle K, is congruent to angle S. Now, once I have the angles, here's why I like that. I can say triangle LJK should be congruent to triangle RTS. Now that I have that, I can do the sides. LJ should be congruent to RT. And then I have JK should be congruent to TS. And then the last one, LK, should be congruent to RS. So we have our congruent statement, we have our 3 angles and our 3 sides. Again, you can do those in any order. It doesn't really matter. You have all the markings that you need to do them in any order you see fit. Okay, so what we'll do next is we'll do a example 2 first, and then we'll do monitoring progress. So again, we have kind of some relationships here going on. We need to find the value of X and Y. What I recommend is identify where your variable is and then use what you know from the other figure. We have a situation where angle Q has X and Y, and then side QR just has X. So we know QR has our equation. We want to pull from over here, QR is congruent to FG. Then what I want to do is I want to go look at FG, and I see that FG is 12. So now I can just plug in 2x minus 4 is what QR is. FG is 12, and now I can solve by adding 4. And then I take 16 and I divide it by 2. So now that I have the value for x, I can take and plug it in here. I still need to know what angle Q is, so I have angle Q should be congruent to angle F. If I look, angle Q is 6y plus, I'm going to plug in my 8, equals angle F, 68 degrees. So I subtract my 8. I get 6y is equal to 60. I divide by 6. Y is equal to 10. So again, you have to kind of work through this problem and make sure you have enough information to solve the parts you need. Once you identify those corresponding parts, though, it should be pretty straightforward. That's why up above, it's so useful to be able to do that. So we don't just stop doing that because we don't have shapes anymore and are being asked to. We still set it up like that to help us solve the problem. Okay, example 3 says you will divide a wall into orange and blue sections along the line JK. It says, will the sections of the wall be the same size, and explain. So first of all, we have to have all parts being congruent in order for those shapes to be congruent. Next thing we see is that we have right angles on all 4 corners. The nice thing about those right angles is that it helps us set up another fact about this shape, is that these lines are parallel. The reason that's useful information to us is now that those are parallel, they are parallel lines that are being cut by a transversal. So JK is now a transversal. So in order for me to have a congruent part or congruent shapes here, I have to know all the parts are, and I have all of the parts except for those angles on the inside. And we can probably pretty clearly tell that JK is congruent to itself. So we probably don't need to do a lot of extra work there. But what I can decide now, because I know those corners are square, is I know that angle 1 is congruent to angle 4, and that's by alternate interior angles. And I can say the same thing for angle 2 and angle 3. So now if I wanted to list out a congruent statement, I could sure do that. I could say polygon or quadrilateral, whatever you want to call it, JADK is congruent to the polygon KCBJ. All of those vertices match up, all those sides match up, so those congruent statements are true. Again, everything else is marked other than the 2 relationships that I have, and then the side JK being congruent to itself. So now I can say those are congruent polygons. Okay, so I've done a lot of talking. We have our first monitoring progress here. Go ahead and pause the video, answer these 3 questions. Again, you can kind of see the answers to them there. But pause the video, try these. Make sure you write them out in your notes. Once you have a second and have paused it, then you can go ahead and check your answer. Okay, so on number 1, if we're identifying all pairs of corresponding or congruent parts, again, we really don't even need the images. All we need to pay attention to is this congruent statement right here. So as you can see, I have A congruent to C, B to D, G to E, H to F, and then I have AB to CD, BG to DE, GH to EF, AH to CF. And those are all the parts. Now, if I were to ask you on a quiz or a test to write another congruent statement, again, you can do that. Just use these letters in a different order, but make sure your vertices match up. So let's just do this. Instead of starting with A, let's start with B. So if I did that, it would be B, G, H, A would be congruent to D, E, F, C. And that's a new congruent statement that means the same thing. Number 2, if I wanted to find the value of x, again, what I want to do is identify where x is. X is at angle H. I know angle H is corresponding with F. So I set 4x plus 5 equal to 105, and then solved, I got x equals 20. Again, in the diagram on the left, show that PTS and RTQ are congruent. So all the sides were marked congruent, and I just put given what we just used a little bit ago in that last example were alternate interior angles. Once again, they give us these parallel marks because those are useful information to us. That means that PR and SQ both now become transversals. So I have the angle P is congruent to angle R by alternate interior. I have Q and S are congruent by alternate interior. And then I have PTS and RTQ are congruent by vertical angles. So that's why I can say those are congruent triangles. Again, some of it was given, some of it I needed to make sure I understood why it was the case. Again, we have properties of congruence in a triangle. We have the reflexive, symmetric, and transitive property. Again, you should have these in your notes. We talked about these several times. I think clear back in maybe chapter 2 or earlier even. But a lot of things are able to use the reflexive, symmetric, and transitive properties. The one that's a little bit new to us, again, it should not be too hard to comprehend what's going on here. But it simply states if I know two angles of a triangle are congruent to two angles of another triangle, the third angles of them have to be congruent. And that's simply because the triangles have to add up to 180. So ABC, the sum of those angles has to be 180, as well as the sum of angles DE and F have to be 180. And if I know two of the three are the same, the third one has to be the same. So using third angles theorem, again, this looks very complicated, but if we take a step back and look at it, it's really not so bad. We want to find the measure of angle BDC. So that's this angle right here. Before we can do that, we need to pull apart a couple of things. So first of all, we know that this is also 45, and we know that this is also 30. So now, if I take that triangle out, so I have triangle BDC, and I'm going to try and draw it here, not terrible. There's B, there's D, there's C. I know part of angle D, but I know this whole angle right here is 30 degrees. I know this angle up here is 45. So if I want to know the angle BDC, that whole thing, it has to be x plus 30 plus 45 equals 180. So I just combine my like terms. X plus 75 equals 180, and then I subtract my 75. So I get x is equal to 105. So the measure of angle BDC is 105. Now, they could go further, and they could say, okay, well, what's the measure of angle NDB? Well, we already know that this is 30, so you would just subtract it. So just watch for the directions on some of those, because it might not always be what the whole angle is. It might just be parts of it. Okay, so again, being that we're learning some theorems, we will have some proofs this chapter. Most of it will use some things, and we'll kind of create ourselves a bank of things that pop up all the time. But none of this should be super new other than the theorems we learned this chapter. So what we're trying to do is prove that these two triangles up here are congruent. In order to do that, we have to prove that all parts are congruent. And as you can see, we have quite a bit of stuff given to us as congruent. So we have the markings on the image are two of the three sides. The markings on the image for the angles are two of the three angles. So what we can use, first of all, is our third side that we want to be congruent is literally attached to itself. And you can see here, AC is equal to CA. Those mean the same thing. That's the same segment. So anytime you say something is congruent to itself, that's the reflexive property. Next, we have ACD is congruent to, so ACD is this angle right here, is congruent to CAB, so ACD and CAB. And then we have CAD, so right here is congruent to ACB right here. Again, those are marked in your image, so those are actually given. And then the last pair of angles we need are these right here. So we can say angle D is congruent to angle B, and that's by the third angles theorem. And now we have proven that all the corresponding parts of a triangle are congruent, so we say corresponding parts are congruent. You don't have to write out that whole thing, so you can say corresponding parts are congruent. Okay, monitoring progress. So again, go ahead and pause, take a second to answer these, and then I'll go ahead and answer them with you here in just a moment. So on this one, find the measure of angle DCN. So DCN is right here. If we look, we know that these two have to be congruent because they're vertical. We know that S is congruent to D, and it is 68 degrees. And then we have to find the measure of angle C, and we can see that it has to match up with angle R. So angle C has to equal 75 degrees. And then what additional information is needed to prove that those triangles are congruent? Well, we have a pair of sides that are marked congruent. So in order for them to be congruent, we need to know, first of all, that NS is congruent to ND. So the other sides that are touching in the middle, those would have to be given as congruent. And then the other pair of sides that we need to be congruent would be RS, would need to be congruent to CD. And then we could say those triangles are congruent. All right, so in summary, again, we were supposed to have used corresponding parts in triangles or in polygons in general. We learned the third angles theorem. We used it in a proof. You have the assignment posted for you. There's a practice set. Make sure you ask questions if you need to. And again, make sure we're taking good notes and staying really well organized. Thanks, guys. Have a great day.